A race car travels on a straight racetrack with a forward velocity of 44 meters per second and slows at a constant rate to a velocity of 22 meters per second over 11 seconds. How far does it move during this time? So let's go ahead and look at the first part. So you have a race car travels on a straight racetrack. That doesn't tell you much. With a forward velocity of 44 meters per second. So forward velocity, so we're going to let the direction be positive when it's traveling the forward direction. And this here, 44 meters per second, is your magnitude. So all of this is telling you the initial velocity of the race car. So I'll write up here, initial velocity is plus 44 meters per second. And slows at a constant rate to a velocity of 22 meters per second. So its initial velocity is 44, and the racetrack slows down. I'm sorry, not the racetrack. The race car slows down to 22 meters per second. So this right here is final velocity. So I'll go up here. Final velocity is going to be a plus 22 meters per second. We're assuming that the car did not reach 0 meters per second and then turn around. Over 11 seconds then. So this is the time. And the next part, how far does it move during this time? So how far, which is asking you the length or distance of it. So this here is displacement. So we're given time to be 11 seconds. And our unknown then is displacement. For the next part, we have to figure out which kinematic equation we need. So if we look at our givens and unknowns, we're given initial velocity. And all four kinematic equations have initial velocity, so this doesn't eliminate the equation. We need final velocity. So this equation has final velocity, this one has final velocity, this one does not, so we'll go ahead and eliminate this equation, and this one has final velocity right here. The next variable, time. We need time. So we look at the first one, time is here, time is here, time is not in the fourth equation, so we'll go ahead and eliminate that one. And finally, displacement. We need the displacement here. So displacement's here, but displacement is not in the second equation, so we'll go ahead and eliminate this. So for the kinematic equation, we'll be using this equation right here. With our selected kinematic equation, displacement is equal to 1/2 initial velocity plus final velocity times time. We'll go ahead and isolate the unknown. Fortunately, the unknown that we need is already isolated. It's already by itself. So I don't have to rearrange the equation. I'll just go ahead and rewrite the equation again. And we can go ahead and move on to the next step. So now we're going to substitute our values in. We're given displacement is equal to 1/2 initial velocity plus final velocity times time. And we'll go ahead and plug in our values. So we have 1/2. The initial velocity of the car is 44 meters per second plus final velocity, which is 22, times the number of seconds, which is 11. Let's go ahead and add 44 plus 22. That gives me 66 times 11. Let's go ahead and multiply 1/2 times 66. That turns out to be 33 times 11. And multiplying 33 times 11, that's 363 meters. So looking at our final answer, the displacement is 363 meters. We want to take note that it's a positive value, which makes sense since the car did not make a U-turn at any point, and that it seems reasonable. It's not too small, like 3 or 4 meters. It's not too big, like 1,000 meters. So our answer checks out then.